Hi everyone, my name is Ani. Welcome to my YouTube channel. Today we're going to be doing something a little bit different than my normal electronics DIY videos. This video is a electronics basics explained video where we're going to dive into a basic electronics explanation, and today we're going to be talking about circuits. So here I have a basic circuit, and what we're going to be doing is going through what a circuit is. And after we're finished with that, then we are going to build a circuit, and I'll show you how the electricity flows. So right here we have a diagram of a simple circuit, which is just a battery right here. This is the power source of the circuit, and we have a light. This is a light bulb, and you can see that the electricity is flowing through the wire, which is the straight lines that I drew, and it is passing through the light bulb and making it light up. So what a circuit is a continuous loop of electricity. So you can see that this circuit is moving in a continuous loop. If you were to cut the loop like this, then the electricity would stop flowing and the lamp would stop lighting. So today we're going to be talking about how this circuit works and some of the small concepts that we need to know to learn how the circuit works. So first, let's begin with the basics. So what is electricity? Well, electricity is pretty much the movement of electrons through a conductive substance. So what do I mean by conductive? So conductive means a substance or material that can pass electrons through it. This includes a lot of metals like copper, which is the main one that most wires are made of, and other things like aluminum, iron, etc. So usually in electronics we use conductive substances like copper to transfer electrons. Now let's talk about what are electrons. Well, as you might know, the world around us is made up of atoms. So the most basic form of what an atom is a positively charged center and circular areas around it, a cloud of electrons, which are negatively charged parts of the atom. So these names, negative and positive, don't really mean much. The only thing that we're saying here is if two things are the same, like a negative and a negative, they will move away from each other. They will oppose each other. Okay? If two items of subatomic particles, let's say a positive and a negative, if they are opposite to each other, they attract, they come together. So in an electrical circuit, I said that the electrons move, right? Well, in normal substances, let's say like wood, the electrons stay in one place. They have a structure, sort of like this, right? They bond together and they don't really move around much. So this would be a very crude example of what wood looks like. But in items like copper, which is conductive, we have atoms that have a positively charged center that keep the structure of the copper or metal, but the electrons will flow freely. So they will be moving around just like that. So what this means is when we send an electron flying into it, then the electron that was once here flies onto the next atom, and then the next atom, and it continues. And a chain reaction occurs where the electrons start flowing through the copper wire. So that is what basically happens in a circuit, where the electrons flow through and all the way back into the battery. So since the electron is negatively charged, the negative side of the battery always flows in back to the positively charged side, just like this. So this might be a little bit complicated to understand, but we can use a very simple and effective analogy to explain this. This is what most people call the water analogy, which is very useful when understanding electronic concepts. So water flows just like electricity in one direction, right? So we can say that this battery here is like a water tank. Just like that. So a water tank has the entrance and the exit here. So we can say that this is the negative side and this is the positive side. So the water flows out through this pipe and the water flows in through this pipe. So this is a battery in terms of a water tank. As the electricity flows through the water tank, just like that, the water will go in through this pipe, which is the copper wire. This is a conductive substance. It'll flow through the copper wire or the tube, and it'll go into some sort of appliance. So for example, here we're saying that the electricity goes through the light bulb, and lights it up. So here we're going to say that it goes into a faucet, just like that. So the water goes in through the faucet and the water starts coming out of the faucet. So that means that the light just lit up. So the water's coming through the faucet, and always in a faucet we have a drain. So there's a drain here, and this drain pipe contains the water that was used already. So this is all the used water. All of the used water goes all the way back through to the positive side. It's like that. So this pipe goes all the way down and up into the positive side, the used water. So you can see by this very simple analogy here, if we use a battery as a water tank and we use a faucet like a light bulb, the water will flow through and back into the water tank. So this is the basic analogy about how a circuit works. So now let's talk about a little more in depth. In a circuit, there's many different laws and kind of physical demonstration of what happens to the electricity as it goes through the circuit. So there's a lot of different words that you may have heard about electricity, like ohms, amps, volts. There's more, but we're gonna keep it simple, just talk about these three today. So let's start with volts, for example. What are volts? So in an electric circuit, how does volts affect it? So again, we're gonna use the water demonstration here to say what volts is. So volts is basically the flow or the pressure of the water. So you can see that the water is flowing through this pipe, right? Just like that. And then it's coming down. Just like that. So as the water flows, the more strength or the more pressure that the water has is the amount of volts. So for example, we can say if we have a hose, the more you increase the pressure of the hose or close down on the nozzle, the pressure will increase and there will be more powerful stream of water coming through. So that's what volts is, basically how pressurized or how fast the electricity is moving. This is normally, you can find how many volts are in a battery. For example, this AA battery right here, you can see right here it says 1.5 volts. So that tells you how many volts are in that specific battery. So that's how pressurized the electricity is. Next, we're gonna go to amps. So this volts is basically the pressure, okay? Amps. What is amps? So amps is the flow of the water, or the flow of the electricity. It's how much electricity is in the circuit. So in this entire thing right here, in this entire pipe diagram that I drew, there's a certain amount of water that's flowing through, right? That is the flow of the water, how much water there is in the entire diagram. That is the amps. So amps are also known as amperes, is how much water is in the entire circuit. So that is what amps is, okay? The flow. Finally, there's ohms. Ohms is the resistance. So when I mean resistance, I mean things like friction in the real world, like friction, that stop the electricity or the water from moving. So ohms is the amount of resistance that's being put on the electricity. So here, the water, we could say that resistance is like if we made the pipe smaller like that in one place, that resists the flow of water, and it makes the water much less on this side compared to this side. So as the water flows through that junction, it gets resisted. So there's more resistance there. That is what ohms is, the resistance. So this is the basic different definitions of these things in a electrical circuit standpoint. So using this water analogy, we can explain what these three things are in an electrical circuit. So we know that the electrons are flowing through the circuit just like this, but now we're going to test it in real life. We're going to see how it works in real life. So here I have some components, like this light here. This is an LED light, just like this one here. So this is our faucet. Next, we have some wires. Here, these are alligator clips, which have aluminum wire stretching throughout. And these are used to connect things together. So these are going to be our negative and positive pipes or copper wires. And finally, we have our water tank or battery source, 2 AA batteries, okay? So in this circuit that we're gonna make, this very simple circuit, there is no resistance, okay? There is no resistance that we're putting on it. It is just the 1.5 volts, the 1.5 volts of pressure being put into the circuit. And that is how much is going to be going into the light. So we have our water tank here, the battery source, okay? So we have our negative and our positive ends. So we know that from this pipe, the electrons will flow. So let us connect our copper wire, or alligator clip. Let's connect it right there. Now we have our other end. You can see the electricity is flowing through this wire out to this end. So right now the electricity is here. So let's connect it to the negative end of our LED. So now the electricity is flowing through, but it is not connected back to the battery source, so it cannot light up. So let's connect it into the battery source just like that. We connect it onto the positive side of the circuit. Just like that. And it should light up. There you go. So you can see that the light has light up and the electrons are flowing through the negative side here, going through the light, coming back into the battery. So that was a very simple demonstration about how the circuit works. So I will be making more of these videos in the future about more in-depth concepts of electricity. So today we talked about a circuit and how it works. If you have any questions, please ask in the comment section and I'll be sure to answer. So thanks for watching. If you want more of this kind of content, I'll make sure to make more of these in-depth explanation videos, and I'll talk about some different components as well. So thanks for watching, and if you want more, please hit that subscribe button, and also hit the bell notification so that you can get notified whenever I release a new video. Thanks.